Okay, so in this video, I'm going to go over numbers 4 and 5 of the review, but I'm going to be also kind of reviewing graphing these functions. So number 4 wants you to graph the exponential function 3 to the x minus 1 minus 6. Okay, before we obviously can graph it in our calculator and we'll get the table, but I want to kind of go over graphing so that we understand some of these key features such as domain, range, and the asymptote. First of all, the parent function of an exponential function is y equals b to the x. Now, if we input a 1 for x, anything to the 1 power equals 0. So for instance, y equals 2 to the x. 2 to the 0 is 1. So when we plug in 0, we get a 1. So the parent function has this point at 0, 1. Now, every other function is going to be a transformation from that point. Okay, so here is the transformation function, a times b to the x minus h plus k, where this x minus h is the horizontal shift, and the plus k is the vertical shift. And the plus k is going to change the asymptote. In the parent function, notice that the line always approaches 0, always approaches y equals 0. That would be the horizontal asymptote, okay? But in this function, that changes. So let's take a look at what we have here. The x minus 1, 3 to the x minus 1, it's going to shift to the right 1 unit, okay? And the minus 6 is going to shift it down 6 units. So when you graph it, you'll see these points on your table, 1, negative 5. Well, 1, negative 5 is a transformation. It's a shift 1 unit to the right because of this, and it's down 6. So over 1 and down 1, 2, 3, 4, 5, 6, and there's your new point right there. And this number minus 6, that is the new horizontal asymptote, which is y equals negative 6. So this graph that you see on your calculator is approaching that negative 6. And then, of course, it's exponential growth going up, okay? So let's talk about domain and range. The domain for this one, you'll see it goes to the left forever and up and to the right forever. It's actually all real numbers, okay? So you can enter anything you want for that exponent, okay? And you're going to get an output. However, the range, notice, the range never drops below negative 6. So it's everything greater than negative 6. So there's your range, y greater than negative 6, okay? The x-intercept, that's where it crosses the x-axis. Looks like it's maybe between 2 and 3 here. I'm not going to worry as much about that one, but the asymptote, we definitely need to know that we call that y equals, this is a horizontal asymptote when y equals negative 6, okay? All right, that's a review of graphing the exponential function. Okay, at number 5, we're going to be graphing this log function, log base 2 of x minus 5 plus 2. So again, I want to review our parent function, f of x equals log x. Okay, so if you find the log of 1, let's say we have an understood base of 10, okay? Remember, the answer to the log function is the exponent. So the log of 1, 10 to what power equals 1? Well, anything to the 0 equals 1. So if we have an input of 1, the output is 0. So here you see with the parent function, it goes through 1, 0. And then the line approaches a vertical asymptote of y equals 0. Okay, I'm sorry, of x equals 0. That's a vertical asymptote. Now, the parent function, again, I'm sorry, this function is going to be a transformation of the parent function, log base b of x minus h plus k, where inside the parentheses x minus h is going to be a horizontal shift. And the horizontal shift is also going to reveal the vertical asymptote. So the opposite of that number is going to be the vertical asymptote, okay, at x equals that number. And then, of course, the plus k is the vertical shift. So let's just real quick look at our shift. So in this function, we're shifting to the right 5 units and up 2 units. So from our parent function 1, 0, we would go over 5, 1, 2, 3, 4, 5, and then we would go up 1, 2. And there you see a point at 6, 2, which is in your table that you would see from your graph on the calculator, okay? So there's that point, 0, 2. Again, it's a shift, plus 5, plus 2, over 5, up 2. Now, the vertical asymptote then, the vertical asymptote is the opposite of this number. We shifted to the right 5, so you see that it is approaching x equals 5 but never touches it, okay? So x equals 5 is the vertical asymptote of this one. Now, as far as the domain and the range, you'll notice it's going down forever and up forever. So the range is actually all real numbers in a log function. However, because there's a vertical asymptote, the domain in this one specifically, remember it approaches 5 but never crosses it. So nothing over here to the left of 5, which would be less than 5, is included. So our domain then is everything greater than 5, x greater than 5. That's where the domain comes from, okay? All right, and the same thing with the x-intercept, just where it crosses the x-axis here. So that is a review of graphing log functions.